I welcome all of you in the course Data Science Using Python, which is a multidisciplinary course designed for learners from any background or stream. I'm Dr. Faisal Anwar, working as assistant professor in the Department of Computer Science, Aligarh Muslim University, and instructor of this course. So, what are the motivations behind designing this course? So, this course is actually designed for the learner so that they can take data science as a separate course. Imagine logging onto Amazon and being greeted with product recommendations on spot. It is like Amazon can read your mind. That is the power of data science. Amazon's personalized recommendation system uses your browsing history, purchase history, and items in your shopping cart to predict what you might like next. Gone are the days of similar advertising for all. Today, ads are tailored to individual preferences, behaviors, and demographics that we call targeted advertising. Thanks to data science again, voice assistants such as Google Voice, Siri have become our everyday companions, helping us find information, control smart home devices, and manage our calendars. They are constantly learning and improving, providing more accurate and helpful assistance over time. We can even use our Siri to contact any person, let's say Mr. X. So I will say, hey Siri, call Mr. X. So these applications are just the tip of the iceberg. Data science is helping industries creating new job opportunities and enhancing our understanding of complex system. You know what happened during this recording when I say hey Siri, so my mobile Siri has activated. That is the power of data science. So let me introduce data as well as data science. So what actually data means and how data science fit in this arena. So data can be considered as raw material, while data science is the process of extracting meaningful information from the data. Data science is an interdisciplinary field that combines statistics, computer science, and domain expertise to extract knowledge and insight from structured and unstructured data. So, this particular course, data science, can be opted by any student across from different streams. So, it would be helpful for students belonging to social science or from arts stream. So, they could also join this particular course. We have designed this particular course keeping in mind a multidisciplinary approach. Now, what could be the application of data science? You imagine any industries, and data science can fit in that industry. Data science would help you to get insight from the data that industries are having. So, data science is being employed in a wide range of industries, including healthcare, finance, agriculture, retail, and more. It empowers organizations to make data driven decisions and gain a competitive advantage. And what are the popularities of data science? Why it's so much popular these days? In recent years, we have witnessed an extraordinary trend. Digital devices are not only becoming more affordable, but also significantly more powerful. This democratization of technology means that advanced hardware and software tools are now in the hands of many. Anyone can use hardware and software nowadays. As we navigate in the internet world, every click, search, and interaction generates data. A report by the International Data Corporation, that is IDC 2021, projects that by 2025, the world will generate 175 zettabytes of data. That is 175 billion terabytes. That speaks huge volumes of data. The same IDC report forecast a paradigm shift. nearly half of the global data will find a home in public cloud environments by 2025. This transition to cloud-based storage reflects a broader movement toward flexible, scalable, and accessible of data. Now we'll discuss the learning objectives of this course. So what are the learning objectives of this course? Which are, the very first is understand the fundamental of Python programming. Under this objective, learner will acquire a working knowledge of Python syntax and controls. They will learn to write Python functions and work with Python data structures like lists, tuples, dictionaries, and sets. The second objective of this course is to gain proficiency in using Python's data science libraries. Under this objective, they will learn to manipulate and analyze data using pandas. Learners will be able to perform numerical computations with NumPy, which is a specialized library of Python. They will be able to create visualization with Matplotlib and Seaborn. The next objective of this course is to develop skills in data manipulation and cleaning. Under this objective, the learners will be able to understand how to handle missing data, duplicate data, and data errors. They will learn data transformation techniques essential for preparing datasets for analysis. The fourth objective of this course is to learn the basics of statistical analysis and hypothesis testing. Under this objective, students will be able to comprehend the concepts of descriptive statistics and inferential statistics, which are branches of statistics. They will be able to perform hypothesis testing using Python to make data-driven inferences. The fifth objective is to understand machine learning concepts and apply them using scikit-learn. Under this objective, the learner will be able to grasp the basics of machine learning algorithms, including supervised and unsupervised learning. They will be able to implement machine learning models and understand the principles of model selection and evaluation. Sixth objective is to learn to present data insights effectively. Under this objective, the learner will be able to develop the ability to communicate results through visualization. They will be able to create comprehensive reports on the findings from data analysis. That is very important. Now come to the learning outcomes of this course. By the end of this course, students should be able to write Python scripts and programs for various data science applications. They will be able to efficiently use Python libraries, frameworks for data pre-processing tasks. They should be able to conduct exploratory data analysis to uncover insights and prepare data for modeling. They will be able to apply statistical methods to analyze data and validate hypotheses using Python. They should be able to create meaningful data visualizations to present findings in a clear and impactful manner. They will be able to build, test, and evaluate machine learning models with scikit-learn, again a specialized library of Python for machine learning. They will be able to demonstrate the ability to extract and interpret data to inform decision-making processes. Finally, they will be able to possess a solid foundation in data science that can be applied to real-world problems across various domains, be it agriculture or health industries or e-commerce. So in any domain, the student can solve the problems related to those domains. Now we'll see the contents of current week. We will discuss Introduction to Data Science. Then comparing and contrasting AI, that is artificial intelligence, machine learning, and data science. We will also introduce Python to you. An introduction to Google Colab will be there. So these are the contents of current week. Now we will focus on data science operations. Data science can be described as a field revolving around 5 data related operations. The very first is collection, then storing, processing, describing, and modeling. So we will briefly describe these operations, and a detailed discussion will be held in later weeks. So what is the collection operation? The very first operation in data science. So data collection is the process of gathering data, which could be text, video, audio, or any other format. Data might be available and just need to fetch from some sources. Let's say a database server, or the case may be where data is not available at all. In that case, data scientists need to design experiments to produce the data. Data collection depends on data scientist and the environment in which the data scientist is working. Let's say a data scientist is working on an agriculture-based company. His task is to find which crops yields higher production, let's say in districts of Maharashtra. He wants to check effect of type of seed, fertilizer, irrigation on crops. In these types of problem, data already exists and can be accessed using SQL. Let's see another case. It is a data scientist working for a political party, and his task is to find the winning chance of a candidate in a particular region. Data exists at different sources such as Facebook, opinion posts, which can be accessed using API or crawler. So a data scientist need to write Python code to access these data. Take one more example where a data scientist working with healthcare systems, and he wants to know effect of new drugs on patients. Here data is not available at all because this particular drug has been introduced very recently. In this case, data scientists need to design experiments to collect the data. As far as essential expertise needed for data collection is concerned, data scientists need to have a knowledge of programming to access data. Knowledge of statistics is also important in case experiments are needed to collect the data. Suppose the data is not available, then in that case, experiments need to be designed. Knowledge of database is also required when data need to be collected from databases. Suppose data exists at databases and you need to collect the data. I mean, the data scientists need to collect the data. So in that case, database would be an essential tool. Now the next operation is storing data. Storing data is the next operation after collection. Operational data is the vital part of an organization. It is generated by day-to-day operations. It is transactional data that reflects the business activities and includes sales record, banking transaction, or customer interactions. Unstructured data and structured data actually are the part of the whole data. So data could be in any format, unstructured or structured. So what is unstructured data? So this data is the wild frontier of data science. It doesn't fit neatly into traditional row and column databases and includes text, speech, video, and so on. Web, social media posts, online reviews, these are sources of this type of data. Data could also be in a structured format, which is highly organized and easily searchable. It is stored in relational databases and is what you typically find in an e-commerce setting in the form of customer profiles. So whenever you are creating a profile in any e-commerce application, let's say Amazon or Flipkart, so your data is actually being stored in a structured format. A particular type of data science problem may need to have data from multiple databases that should be combined into common repositories. Now, what all expertise are needed for storing data? As far as essential expertise needed for data storage is concerned, data scientists need to have a basic knowledge of programming. For this activity of data science, a basic knowledge of database is also required to store the data. If data is stored or need to be stored in NoSQL databases, then understanding of NoSQL databases like JSON, XML will be very much helpful. Now, the next operation of data science is data processing. This is the third operation of data science, which includes several activities such as data wrangling, data cleaning, data scaling, and so on. Data wrangling is the process of transforming and mapping data from one raw data form into another format. Suppose your data is in raw format. So data wrangling can be utilized to transform into some structured format. This process needs to extract raw data, then transform and structure to a particular format and then load the data. Data cleaning is the process of filling missing values in case a record is having empty data against a field. It also includes correcting spelling errors and identify and remove outliers. So what is outliers? An outlier is an observation that deviates significantly from other observation in a data set. It could be very high or very low. So that is actually an outlier. You can see here, suppose your data is in XML format and you are storing it in row column format that is suitable for databases. So that is the process of wrangling, data wrangling. So when you are storing it in database format, so you can easily access these data later on, and the data can also be easily searched. So it is very effective way of storing data into a particular structure format. We usually scale the data to a common unit as well. We normalize values to bring them into a common scale, making it easier to compare and analyze data. Generally, we use min-max normalization, where we scale the values to a range of 0 to 1. We can also scale it to some other values as well. We also want to standardize a set of values where we first calculate the mean and a standard deviation of the data. Then we subtract the mean from each value and divide by the standard deviation to obtain standardized values with a mean of 0 and a standard deviation of 1. How to calculate mean, standard deviation and others will be covered in later weeks. To perform the activity of data processing, one should have programming skills and basic knowledge of statistics. A basic knowledge of database and an understanding of NoSQL database like JSON, XML will be very helpful. Or you could say next operation of data science is describing data, which is the fourth data science operation. For this purpose, descriptive statistics, a branch of statistics will be used, or you could say will be applied, that will provide us with a powerful way to describe and summarize data. Data visualization will help representing data graphically to uncover patterns, see trends, and communicate information effectively. Summarizing data involves reducing large data set to their basic essence, such as mean, median, mode, and others. So all these will come under describing data. As far as expertise needed for describing data are concerned, descriptive statistics will be very much helpful, and programming such as Python and its advanced libraries such as Matplotlib and Seaborn will be very much useful. Now the last stage is data modeling. The last operation of data science is data modeling. This data modeling operation establishes the relationships within data. There could be two different categories of modeling: statistical modeling and algorithmic modeling. Statistical modeling is a traditional theory-driven approach. It is how we highlight the hidden connections between variables in our data set. Under this modeling, we can explore relationships between variable, let's say x, and y of a data set. For instance, in medical studies, we often find that the number of days of treatment, let's say our x, has a linear relationship with blood pressure levels, let's say our y. So this x is independent variable and y, that is the blood pressure level, will be the dependent variable. We also want to model the data distributions. Is it normal, binomial, or something else? This understanding is crucial for making accurate predictions and informed decisions. Now let's shift our focus to algorithmic modeling, the power of machine learning. It is alternative to statistical modeling when the relationship among output and input variables are not simple but a complex one. And if you only care about the prediction and not about the why certain things are happening, so these models are for you. Here we are comparing statistical modeling and algorithmic modeling. Statistical modeling are simple while algorithmic modeling are complex. Statistical modeling are more suited for low dimensional data, that is the data which is having less number of columns, or you could say parameters, while algorithmic modeling can work with high dimensional data. Statistical modeling are data lean models. It can work on low quality of data, while algorithmic modeling works best for large volumes of data. Statistical modeling are more about statistics, while algorithmic modeling are machine learning and deep learning based models. Linear regression, logistic regression, linear discriminant analysis come under statistical modeling, while algorithm modeling includes linear regression, logistic regression, linear discriminant analysis, decision trees, KNN, SVM support vector machines, naive-Bayes, multi-layered neural networks. So in a separate week, we will discuss all these models. So what are the expertise needed for modeling? Modeling activity needs the skills of inferential statistics, which is again a separate branch of statistics, probability theory, machine learning and deep learning knowledge of Python packages and frameworks such as NumPy, Pandas, Scikit-learn, TensorFlow, PyTorch, Keras are essential. We'll discuss separately these advanced Python libraries such as NumPy, Pandas, and so on. So to summarize this lecture, in this lecture, we have seen motivation behind the data science. These are the motivations for you as a learner, as well as motivation for us to design this particular course. We have seen popularity of data science and the reason behind popularity. We have discussed briefly the operations of data science. Now I am stopping here and will meet again in the next lecture. Thank you so much.